Hello, my name is Marina Safronova and this is my Capstone project, TravelMate. TravelMate is a multi-agent AI travel planning system designed for family-friendly trip planning. The main goal of the project is to generate realistic travel itineraries by combining retrieval augmented generation, external live data, travel rules, and collaborative AI agents. Unlike a simple chatbot, the system reasons about weather, travel pace, family constraint, budget, and destination-specific knowledge. The system is built as a multi-agent architecture. Uh, Different agents have separate responsibilities. Preference agent extracts travel preferences. Location agent retrieves destination-specific point of interest from Iraq knowledge base. Weather agent retrieves live forecast through an MCP integration. Itinerary agent creates a trip plan. Constraint checker validates the itinerary using travel rules. And synthesis agent generates the final response. Project uses custom Python orchestrator and the shared application state. Here's an example of a real user request. The user specifies destination, travel duration, family composition, budget, pace, and interest. Orchestrator now coordinates multiple agents. The system retrieves raw data, fetches live weather, applies travel rules, and generates the itinerary. The generated itinerary adapts to weather conditions, family-friendly pacing, available attractions, and budget constraints. The system also provides source attribution for transparency. Here we can see which points of interest and travel rules were retrieved from the RAG knowledge database. The application includes observability features. Agent trace shows execution order, latency, reasoning steps, and decision metadata. This makes the system easier to debug and evaluate. The application also tracks metrics, feedback, IP usage, and audit logs. The system also handles adversarial and unrealistic requests. For example, this prompt attempts to bypass travel constraints and overload the itinerary. However, the constraint checker still applies family pacing and weather rules, and the system keeps generating a safe and realistic plan instead of blindly following the prompt. Technically, the project combines several modern Gen AI patterns. The RAG pipeline is implemented using Chroma Vector database, OpenAI embeddings, and structured travel datasets. Weather Agent integrates with an external weather service through an MCP-style client-server architecture using STDO transport. I intentionally selected a custom Python orchestrator to keep the architecture lightweight and extensively for future migration to workflow systems. The system also implements structured logging, rate limiting, PII anonymization, audit trails, and graceful fallback handling. The project includes automated LLM behavior tests. Test coverage includes positive scenarios of supported destinations, adversarial prompts, weather fallback logic, and RAG validation. Due to demo time limits, I am showing the completed execution results instead of running the entire suite live. The goal was not only to generate responses, but also to ensure predictable system behavior under each case. In summary, TravelMate demonstrates how to multi-agent systems, RAG pipelines, and MCP integration can work together in a realistic AI application. Thank you for watching.